Guys, so let's talk about Le Chatelier's principle. So Le Chatelier, that's this guy, he was a French scientist, and he just made a lot of observations about equilibrium, which is why this is named after him. And his big principle or understanding is that when a system at equilibrium is placed under stress, the system or reaction shifts in such a way to relieve the stress. I mean, think about it this way. If you walk in to your classroom and you find out there's a test that you had no idea about and you didn't study for, your body, the system is under stress and you're going to do things to relieve it. You're going to, you know, let out a groan of frustration. You're going to maybe run down the hall, try to skip class. There's all kinds of things that happen when your body is under stress. And so equilibrium in chemical reactions kind of do the same thing. And so here, what this kind of means, though, in just kind of layman's terms, just things you can understand, is that when you take something away from a system at equilibrium, the system shifts towards it to replace what was taken. For example, if your mom or dad takes away your cell phone, you're going to shift towards whatever it will take to get that cell phone back, right? Whether that's getting your grades up or cleaning your room or whatever those things were, you're going to do whatever you can to get towards equilibrium. And that is a stress on your system. Now, when you add something to a system at equilibrium, the system shifts away from it to use up what was added. And so we see this, for example, I've had students who walked in, saw we had a quiz or a test, and ran down the hallway. They were going away from the thing that was causing them stress. Or maybe when something is added to your plate, you just kind of shift towards the end goal and product so that you can just kind of get rid of this stress. So there are a couple types of stress that we're going to talk about. So the first one is about changing the temperature. Now, when we change the temperature, it's going to depend on whether or not the reaction is endothermic or exothermic. And this is because that means heat will be on one side of the equation or another. So for example, if I have heat plus A produces B, right, that would be an endothermic reaction. And if I add something to it, if I increase the temperature, I add heat, it would shift it towards the right. But if I took it away, it would shift it towards the left. And that would change if it was exothermic and had heat written on the right side. The direction that those things would occur would change. And so the second thing that is a stressor is the concentration or the amount of things. You can add more reactants, you can take them away, and the shift will depend on whether or not the compound is a reactant, meaning it's on the left side, or it's a product, meaning it's on the right side of the arrows, that center section. And we can also change the pressure. But changing the pressure, which also has an effect on the volume or amount of space, will only affect the system if there are gases present. If there is a high pressure, okay, which means low volume or a small amount of space, then the reaction will shift to the side with the smaller number of moles. So think about high pressure, small space, small number of moles, low pressure, big space, high number of moles. And if there are equal amounts of moles of gas on both sides of the equation, then there will be no shift or change. Look at how this can be applied. So we have a closed container of ice and water at equilibrium, represented by this equation. And what's going to happen is the temperature is increased. Now, when the temperature is increased, that means we're adding heat. Okay, and so remember our phrases are add, away, and then they said take, towards. So those are going to be our phrases to help us. So if I add heat, which is here on the left side, then I will shift to the right, which is away from the left. So equilibrium will shift towards the right to use up the added energy. And so that means the amount of water, because it's on the right side, will increase, and the amount of ice will decrease because it's being used with that added energy. Then B, we have a closed container of dinitrogen tetroxide and nitrogen dioxide at equilibrium, and it's in this equation here. And what's going to happen is NO2 is added to the container. Now, if I add more NO2, which is on the right side, remember, add away. So away from the right side would be to the left. And so the amount of dinitrogen tetroxide will go up, and we'll be using up some of this extra NO2. We could also see that shifting to the left will increase the heat that this reaction is putting out. And so the next one, the closed container of water and its vapor at equilibrium. So we have water plus energy equals vapor, which is, the gaseous form. So what we have here is vaporization or boiling kind of happening. And what happens is vapor is released from the system. So if I release it, it means I'm taking vapor out of the container. So remember, the phrase is take, towards, and that means it moves towards what was taken, so in the same direction. So if I take vapor away, then equilibrium, which you can consider equilibrium as the center at these arrows, will shift towards it in the same direction, so it will shift towards the right, which means the amount of water and energy will have to go down. And D says a closed container of the same reaction we were looking at earlier, but this time the pressure is increased. Now remember, when pressure changes, that means we're only looking at gases. And so because of this parenthesis G, we know that both of these substances are gases. And so when you think about a gas, think about a syringe. So if you have a syringe and it has like a plunger in it, right? Anytime you push the plunger down, you're increasing the pressure, and the amount of space that you have, what I'm coloring in black, is going to get smaller. So if I increase my pressure, I decrease my volume, so I have less space. And so because I have less space, I want to, equilibrium will shift towards the side with the smaller number of moles. So if we look, N2O4 has a coefficient of 1. So on the left side, so the left has 1 mole of gas, but on the right side, the right side has 2 moles of gas. And so we have less space, so we want the side with smaller, so it will shift to the left side because that's where the smaller number of moles are. And so the rest of your packet, guys, is practice problems, and these problems are really excellent for your test that is tomorrow, because this video is being made on Thursday. And so I hope you will really practice with those and really look at them. If you have questions on them, please let me know.